Welcome to Insider's Guide to Energy EV miniseries. I'm Chris Sass, and with me is Neil Riddell. Neil, what's going on?
Hey, Chris. Busy day in paradise as per usual.
Another busy day, but the EV miniseries is really coming along, and we've had some amazing guests. Super excited about this episode. Maybe you want to share with the listeners what we hope to do today.
Yeah, so this is something I'm super excited about. When I first started getting into the world of distributed energy, microgeneration, the energy transition, I came across this crazy company out in the US who are building battery storage. So today we're speaking to Tad Glauthier about how STEM is supporting businesses as they transition to electric vehicles. So probably a nice, easy place to start, Chris, if you're good with it, is, hey, Tad, can you tell us a bit about yourself? Where did you come from? How did you get here? And, what might younger listeners who are maybe new to this platform learn from you?
Hey, Neil, thanks for having me on and good to be here. Yeah, so a little about myself. I'm the vice president of eMobility, and I'm also part of the founding team at STEM. I've been with the company since we got started in San Francisco in 2009. And that was really before there was much of an energy storage industry at all. STEM really helped to build it. And we're kind of the first smart energy storage company to go public in the US. Um, and so it's been exciting to see this industry kind of come to pass over the past decade or more. What our kind of core business is as a company is we use software with large batteries to help companies, businesses save money on their electricity bills, but also support the grid, help the grid be greener and operate with more clean energy. We're with over 30 of the Fortune 500 companies. They use our technology, and we're the largest energy storage virtual power plant operator in North America. Um, and it really is it comes down to us being a software company. We've got a core platform called Athena that is a clean energy management platform, and it really helps to allow the batteries to store more renewable energy. You can't use you can't use solar energy when the sun's not shining. Right? The sun doesn't shine at night. The wind isn't always blowing, and so it makes it possible to use renewable energy, those intermittent sources, more and accelerate that adoption. And it also is a way for companies to save money. So we're really focused on kind of those two benefits, and every site's different, and so there's an AI engine needed for uh, to operate a battery at every site where there's a different set of conditions. So that's really kind of the core of who STEM is and what we do.
So what I've heard so far is you were doing battery storage before it was cool to do battery storage, right? You guys were the early innings of what went on. You developed a platform, of software platform to help folks manage it and micro and help Fortune 500 companies along the way. I guess we're on an EV podcast, right? And so we were talking about the greening of everything. So turn the clock ahead from 2009 to today. Everybody wants to be green. Everybody says they're going to drive an electric vehicle. Where do you play? I mean, battery tech absolutely falls into it, but how do you fit into this ecosystem?
Yeah, it's a good question. So, when we look at EV charging, we want to think a little bit about where's that energy coming from that's going to charge those vehicles. The mission of electrification of transportation isn't just swap out a gas powered car for an electric car and then use more fossil fuel on the other end of the grid to charge it, right? That's just kind of moving the problem around. And so we want to bring our technology to the electrification of transportation so that more renewables can be used to power that transportation. And that means using renewables both at the locations where those vehicles are charging, but also remotely, that renewable energy that may be far away on the grid. Again, that's wind that gets produced at a different time or solar that's produced at a different time than the vehicle needs it. You've got to have batteries somewhere in that system. And so we're looking at this from kind of a top down perspective and going, hey, there's an amazing amount of load that is coming to the grid. When we looked at the projections for load just in North America over the next about 15 years, you currently have about one third, one third, one third in terms of electricity use in the United States in particular, which is residential, commercial, and then heavy industrial. The electrification of transportation is adding a whole another third. So effectively, as much electric load as we use in the entire residential or the entire commercial sector today is going to be added to the grid. All that energy's got to come from something, and we don't want to be burning more and more fossil fuels. We're trying to build the renewable resources, and that includes building out the battery storage and having the smart software to be able to manage all that distributed energy in a more it's just a much more complex system than what you'd have with the kind of old hub and spoke model with big fossil fuel generators. So that's where storage and smart software comes in at the highest level.
So that's really cool. We had a speaker on previously who was talking about their experience with the grid. The grid can't cope. You just told us a third, 30% more is coming onto the electricity system to provide services for these vehicles. So effectively, what you're doing with your battery storage is enabling that ecosystem to operate. Now, the other thing you said at the start was Athena is your platform to enable this to happen. Athena wasn't born overnight. What was that journey like? Tell us what happened that took you from the first couple of units into something which is basically helping the grid expand by another third.
Um, yeah, I mean, it sure wasn't born overnight. We started out um, by needing to collect data. We recognize that we've got to start learning and being able to predict what loads are going to do, be able to predict what renewables are going to do, and bring data sets from other places, like bring in a weather feed into this platform. But like every startup, we have humble beginnings. Our first data monitor was a laptop inside of a shoebox that we had under the manager's desk in the back of a coffee shop, and the next one was under the manager's desk in the back of a car wash. And so those two first customers were really important to us, starting to gather data sets and understand how do loads change, what happens when you apply a battery to those loads, how can you reduce the impact on the grid from changing load. That moved into the combination of changing loads and changing renewables. We started doing lots and lots more projects with solar, partly because of the tax structures in America. The solar tax credit could be applied to the cost of the battery. So we started seeing lots and lots of projects that were solar and storage together. And so Athena kept on getting kind of smarter and smarter. And as we recognize kind of there's these renewable generation sources, there's load types. We looked at the other sort of energy assets in the ecosystem and said, hey, EV charging is a whole other category of energy asset that Athena can manage. And EV charging is great because there's all this digital information that it can send over to our platform. And so when we think about kind of this AI engine just kind of feeding off of getting more and more data in from the world around it, a lot of times EV charging platforms, if it's a fleet charging platform, for example, where vehicles go on a regular basis, it might know its own schedule and it could tell us what its schedule is. Public charging is a little bit more tricky to predict, but our kind of history is in prediction. We have a history of learning how to predict load shapes of all different kinds of industries, and some are harder than others. Public charging is currently pretty hard because there aren't that many cars out on the road. So it's hard to guess when any individual car is going to stop at a public charging station. But as we get more and more electric vehicles on the roads, public charging will start to look a lot like regular traffic patterns. They'll be more predictable. And so we're still evolving, and that's part of the exciting part of where we are in the evolution of the industry right now.
So you brought up an amazing buzzword in the industry today, AI, right? The AI genie is out of the bottle for many folks, right? Where folks think that there's different things. And then you talked about these data sets where you're saying the public's hard to get the public charging and things like that. How is the AI helping you do the prediction going forward? I mean, I don't assume it's doing the Chat GPT thing here. I think you're doing some different things along the way. And are you using it on both sides? So on the power generation, so that I know when I'm charging, I'm getting green power, or am I just getting power and I'm trying to predict the loads? Help me understand what you guys are up to.
Yeah, well, boy, there's a lot there, but let me see if I can kind of hit on one or two of the key points. I mean, I think um, we were doing AI before it was cool too. we've been talking about this for a while and doing it for a while, and so to give you a little glimpse into kind of the way that we think about AI in our industry is a big part of our ability to save a customer money is around understanding what their load shape's going to do. And it's kind of like when you're going up a mountain, if you were trying to guess how thick that mountain is, you're going to go up it, you're going to go across it, and then you're going to come down the backside of it. And if you think of a load that same way, what we're doing with a battery a lot of times is trying to reduce peaks in a customer's use. And so we have to guess how long they're going to be because we have to have enough battery to reduce that whole peak. Um, and those loads are different within different industries. And so we have different families of algorithms. And whenever we bring a new site on board, we'll try out the algorithm that we think is best for that based on our experience with other sites in that industry. But we're always developing subcategories of algorithms where different variables get weighted more. And so, for example, some buildings have more air conditioning and more exposure to the temperature outside, and their load will change more when the weather changes. Others are more like industrial processes that maybe don't change that much when the weather changes. And so you weight the weather differently in your forecast of what the load's going to do. And so that's what I mean by AI is really that there is often a human in the loop who's evaluating on a monthly or a yearly basis, how did this do? Maybe we're changing the algorithm family that we've got a site assigned to. Um, but there's a real time decision that's getting made that's specific to every single location, forecasting, and then deciding what to do with the battery in order to deal with those circumstances. So, really exciting stuff. And you mentioned greenhouse gas. We're also bringing in a signal that says, here's the greenhouse gas of the energy, the greenhouse gas kind of weight of the energy right now on the grid. So if we want to weight the algorithms to care more about that, we can say, hey, be sure to only charge when the grid is above a certain level of clean energy, and discharge when maybe the grid is running real carbon heavy, so that the customer is using the clean energy you put in earlier. So that gets us back to fleets, right? Some fleets want to charge cleaner, and so we can kind of tie this back to the EV theme there. But that's something we can do for buildings as well.
So I'm a real big fan of this question of carbon on grids because it's a very very nuanced question. How do you do that? What carbon intensity do you look at? Do you look at the local carbon intensity, a regional or a state level carbon intensity, or do you look at something that's national? And do you consider things like the marginal intensity, so the last plant that came on, or do you look specifically at the average during that given half an hour?
Yeah, again, there's a lot there. I mean, those are great questions. The way that we bring that in the same way that we bring in effectively a weather feed. We use a third party API, and so we're not calculating the carbon intensity on the grid at any given moment. We're getting that from someone else. There's a whole specialty field within that of doing that. But I will kind of circle back to the question around kind of where does the carbon intensity matter? And this is what some of the I think that the leaders in the corporate world that are kind of taking the most forward looking steps are doing is they're thinking about, you have Microsoft, for example, not just buying clean energy RECs and saying, hey, we used this much energy, so we're going to go buy, X energy, X wind over in Wyoming. But they're looking at it more from, we need 24/7 renewable energy that's matched to the load that's on the same grid as our usage, right? So if they want to build a data center somewhere, then they need to be within the same portion of the distribution grid. And I think you can interpret that differently, but the United States grid is mostly all connected with the exception of ERCOT. But really, you're trying to stay within your distribution grid or sort of your region. So I would think of it from that perspective, where I think that's the way of the future. If you think about trying to decarbonize the entire planet, that's what we have to achieve, right? We have to get to 24/7 matched renewables to our load, and that requires storage, and it requires distributed resources being near the loads.
So, so to go back to more EV centric. So in our pre-show conversations, we talked about fleets and the kind of things that you do as an organization. There's a couple of rather large brands that you work with. Um, maybe let's start with maybe like a customer example of what kind of things you're doing. That might be good for the next part of this conversation to see who kind of used your technology and how.
Yeah, sure. Well, we recently announced a project with Sysco, and this is Sysco with an S, the food distributor. That is one I'm really excited about. We've been working on this for a year and a half. The Cisco team had been working on this for close to 5 years, and we just did a kind of pre-ribbon cutting or an early ribbon cutting on Earth Day about a month ago. And it's just a really, a lighthouse project for all of the technology partners involved and for Cisco itself. What we're doing for Cisco is they are electrifying a fleet charging hub. So Cisco is the largest food distributor in the world. They operate in about 90 different countries. They've got about 70 different major hubs around the United States that have, if you can imagine, kind of 18 wheelers that are bringing food to everything from restaurants to retirement homes to schools, and that's critical. They've got refrigerated, cold supply chain, frozen supply chain. That's critical infrastructure that it functions at all times, and they need to go green. So Cisco's taken a great leadership position. They have signed up for climate goals that are in alignment with the Paris Climate Accord. They are electrifying 2,800 of their 18 wheeler vehicles. They're Class 8 trucks over the next between now and 2030, and that's about a third of all their Class 8s. And so this charging hub, to kind of bring it down to sort of what is STEM doing with that project, this charging hub starting out with 40 Class 8 trucks and all electric and electric refrigerated trailers to go with them, 20 high power DC fast chargers. And then on the roof of this refrigerated warehouse, they're building 1.5 megawatts of solar. That's a big solar field. And we're putting in 4 megawatt hours of battery storage. And STEM's Athena platform is managing the power flows of that whole site. So on a site like this, it's pretty common when a fleet is building a big charging depot, they're going to get a new meter from their utility. So they've got existing meter for the refrigerated warehouse. This new meter will have all these clean energy assets on it and really nothing else. It'll have the solar field on the roof. It'll have the battery. It'll have the chargers. And then in case of an extended outage, it'll have a small natural gas generator. And our Athena power controller will sense when the trucks are out, there's no load, so that the solar will be producing during the day. The trucks are out running their operation. It'll say, okay, put that solar energy into the batteries. When the trucks come back, they'll want to charge up by about 4 o'clock. The trucks come back. Well, that's about the worst time of day that you could charge from the grid. That's the most expensive energy, and it's starting to be some of the dirtiest energy when we're having to fire up peak power plants. So at about 4 or 5 o'clock, instead of charging from the grid, we'll be charging from the batteries. And if there is an outage, then our power controller will operate the solar and the storage first to keep the charging going. And if it's needed, then it'll turn on this natural gas generator. So we're operating that microgrid, but really with a prioritization of using all the clean energy first.
Now, isn't it easier in some sense because those delivery routes are well known, right? So, like you have, and Neil's, for those of you listening, Neil is making faces at me and shaking his head because he's been in the EV business for some time and he thinks it's a loaded question. But I mean, I, I just wonder, you have predictable routes and predictable delivery schedules. Is that somewhat easier, or do I need a bunch of AI to do all this?
It is easier, and Cisco is taking the operation of their fleet very seriously. They generally have almost twice as much battery as they need in these vehicles to do the routes that they'll have them running. Um, so as far as the operation of the fleet and the paths that they go on, those are fairly well known, and you don't need a lot of AI to kind of make that solution set better. Where the AI comes in really is in making the choices around that clean energy use on site. So if you think of um, the solar, for example, the solar production is going to change on a day when it's cloudy. And so we've got to know, hey, there's not going to be as much solar produced today, but we still need the battery to be full by 4 o'clock. Well, when should we charge it? How much should we charge it? How much is that going to cost? So making those kind of decisions every day so that this system operates in a cost effective way too, right? That's one of the big trade-offs that a company like Sysco has the leadership and also has the balance sheet to make, is these vehicles cost more than their fossil fuel counterparts, a lot of times about twice as much, but they're cheaper to operate. And so you got a higher upfront cost, but you have a lower operational cost. They need fewer repairs, and that electricity bill becomes their new gas bill, right? So we're trying to help them keep that electricity bill as low as possible by using that AI to constantly make sure we're doing the best that we can for Cisco in what their fuel bill will be.
Yeah, this is a super exciting area. If I was going to turn Chris's question around and say how hard this is all about a battery that is sometimes there and sometimes not. And the idea that you're using your Athena platform to learn you've got a closed environment to some extent because they're coming and they're going, so you're learning the behaviors and the patterns. But this could get very quickly very complex, particularly if you can consider vehicles moving to different depots or different locations, maybe mixing up the vehicle types. The bit that blew my mind was I had to go and look up Sysco. I thought you were referring to the Sysco with a C. I looked up Sysco with an S. I looked into the project and I was like, these are big vehicles. They're classic HGVs. It's the bit of I was in the conference recently. They were talking about electrification of trucking. This is exactly it. It's happening right here and now. Big loads moving around. What do as you go from that nice, simple case study into something which is much more dynamic, different locations, maybe the public charging? What do you hope to learn? What happens next? Where does the complexity go? And what does Athena need to handle as you go into this more and more complex ecosystem?
Yeah, I think where you were going in part is that the notion that for a company like Cisco, they've got trucks that might move around the country, and so as the ranges get longer and longer on these vehicles, right? So right now you might have a 150-mile range, 200-mile range, but pretty quickly we'll have vehicles with 300 miles, 500 miles, 600-mile range. Um, we need to look at it from a system of systems perspective and say, okay, where should we actually be charging them? If we have the option between somewhere in Western Arizona, or should we charge this truck that's headed to the port of Long Beach? Should it wait until it gets there and charge there, or somewhere in between? Um, and the answer is going to be, it depends. It's always going to be changing. It's going to be based on, well, how much renewable energy is on the grid in California right now? Is it different? Is it a different mix if they charged, at the beginning of their route instead of halfway through? And that's where I think some of the really exciting partnerships that we have in place will grow. STEM's partnered with some of the charging network providers. We have partnerships announced with InCharge Energy and with ChargePoint, and those both have really kind of different focuses. ChargePoint is more focused on kind of public charging. They are really a household name and have more charge points in the country than any other provider. InCharge was really purpose designed to serve fleets and commercial kind of depots like the one that I've described, and is the provider of the charging on the Sysco project. And that the way that I think that system of systems kind of methodology evolves is through partnerships with companies like that are aware of where are the vehicles, right? So we're managing the power flows at the individual site. That charge provider knows where the vehicles are, when they're going to be back, and that kind of, and we can kind of develop and imagine advanced product offerings where we're really optimizing for the whole system.
This is a very exciting space because you've got very big systems with very big batteries and very high powered charging. This is going to go on a long journey, but it's relatively new to people. One of the things we mentioned in the pre-show conversation we had was the STEM Academy. How do you help people on this journey? What do you guys do to support people as they come to this ecosystem? They're learning new skills. They want to upskill. What do you guys do to support younger generations coming into this space?
Yeah, so we have a portion of our website that's kind of walled off. You've got to get permission to get into it. It's called STEM University, and we built STEM University for the solar industry actually, because the solar industry was fairly well matured. You have lots of what we call the long tail of solar developers out there who were experienced at doing solar projects but not experienced with doing solar and battery projects. And the battery storage component of a project is the more technically involved component. The need for advanced software just isn't hasn't been there in solar. Right, solar is all about kind of getting your cost of your product down. We kind of say solar is a hardware business, and battery is actually a software business. The key with doing a battery project is having software that is able to really optimize and drive as much value out of that expensive asset as possible. So we set STEM University up to enable the solar industry to do solar and storage projects. And what you have in there are video classes on how to talk about battery projects with your customers, how to do the financial evaluation, build a pro forma of a battery project, and then how to install batteries. There are basic tools like spec sheets and installation manuals in there as well. So there's a whole library of actual resources next to the video modules. And where we're going with EV, I think, is a very similar place where we're now seeing a whole kind of class of EV developers coming out of the woodwork like solar developers and building out EV charging stations all over the country and all over the world. And where it's useful or additive to have a battery as part of that project, we want to enable that whole category of developers of EV to do their battery projects and not have to become experts in it. And we really want to partner with kind of that industry broadly and provide them that expertise. So, yeah, for individuals who are interested, we particularly focus on kind of that developer type, and that's what we're expecting to, the market we're expecting to serve with STEM University. So individuals who are interested in that and kind of fit that profile should just go on our website, look for STEM University, and there's a little button that says, contact us if you'd like to have access.
So I think our audience is generally an inquisitive audience. So I'd expect you'll get some feedback, or you wouldn't listen to an energy podcast on EVs if you aren't inquisitive, wanting to learn. I guess I want to go back a couple steps. We talked about one of the fleets in particular that you're one of your case studies. You gave an example of Sysco, and my esteemed colleague had to look them up. I don't think you can drive around a North American road and have not been behind a Sysco truck at one time or another delivering to restaurants or commercial places, because they're everywhere in the U.S. But there's other fleets that you work with as well, right? I mean, I think you've talked about Penske and some other brands that you work with. Um, and I notice a trend that you're working with heavy vehicles, right? You're working with big things. Is that because it moves the needle? Is it a different problem statement? Is the economies of scales? Like why that focus?
Yeah, great question. Part of the reason for that focus is if you think about kind of our history and where we come at the energy industry, the energy landscape from as a battery provider and a software provider for those distributed resources, we are looking for pockets of load that are fairly substantial. To do a project like ours, you've got some fixed costs involved, and so we don't really put batteries into small places like little coffee shops. We provide batteries to buildings that are the size of a good sized grocery store or larger, and that's partly just because there's fixed costs we're trying to cover, and we're doing a lot of cost saving with our technology. And so where you see that kind of electricity load from EV charging is typically fleets, right? It's commercial fleets that are charging a large number of vehicles all in one place. So you have some rental car agencies, for example, are electrifying their fleets, and that would create enough of a kind of a load pocket to need solutions that are on the scale of what we provide. And then, of course, heavy duty charging. When you think about these trucks, the same with school buses and larger vehicles, just a few high powered DC fast chargers can create 500 kilowatts, a megawatt of load, right? Where you think about public charging is also going to be kind of hitting on that scale. So the NEVI funds is probably a good kind of federal incentive to bring up here. The federal government is putting $1 billion a year for the next 5 years into this kind of chicken and egg problem we have with there's not enough fast charging along the highways to get people comfortable to switch over to electric. So, okay, we'll build the charging out and then people will switch. I mean, that's kind of the thinking, right? Well, each of these NEVI funded sites, and NEVI stands for National Electric Vehicle Infrastructure. It's a federal program that'll basically pay for 80% of the cost for a site owner who wants to build fast charging by the highway. So each one of these sites though has a requirement. They've got to have 4 fast chargers at a minimum, and some will have lots more. Some might have 12 or 15, whatever it is, 20. But even just 4 DC fast chargers, that'll create a little load of 600 kilowatts, right? Each one of those has to be 150 kilowatts or more. So if you think about a convenience store with a little gas station, a little quickie mart or something like that, that might have a load today of 60 kilowatts. And they want to apply for this, and they get selected, and they're building charging on their in the corner of their parking lot. Now they've got 600 kilowatts, minimum. So they're changing it by a factor of 10x their impact on the grid right there. And that's an opportunity to bring in renewables and battery to help manage that.
So I'm going to ask a rookie question, and I'm sure Neil would probably laugh at this. But as we're talking, buses and trucks and they're EVs, definitely by definition, they're an electric vehicle. Is bidirectional charging even something that you consider at this scale, or is that not something? Because I mean, their core competence of Cisco is getting the food to where it's needed, not being in the energy business and shaving energy prices. So explain that how that works, or maybe like please help educate me.
Yeah, that's a great question, and you're right. For Cisco, someone with an operation that is really critical, their view is the operation, and I'm speaking, my opinion is their view, but for many of these fleets that are electrifying, the first priority they have is consistent operation. And Cisco, uh, they deliver food. That is their mission. It has to get where it's going, and it has to still be fresh. um, Same with a school bus operator. They deliver kids, and they've got to get them where they're going. And so for the most part, what we see with operators who are electrifying is their first concern is getting all the wrinkles out of their operation, and that might take a couple of years. They've got driver training that they've got to do. They've got operational changes to their facility. They need to park their vehicles in a different way. They might need to lay their parking lot out differently, and then managing the charging. Their kind of first consideration is getting that charging to work every time. If they leave that charging until overnight, and they go, okay, I'm going to put this on a timer. I'm going to have it charged from midnight to 6 a.m. so that my electricity bill will be lower. And they go home, and they come in, and something happened, right? They didn't, and the charge didn't occur. Well, that's a major disruption to that operation and a real setback for electrification, because it kind of reinforces these fears of, oh, I can't rely on electric vehicles as much as I could my old vehicles. So we've got to get through that set of hurdles. And that's where kind of 95% of the operators of all these different fleets that we talk to, where they are in their journey right now. There is a next phase, which is around kind of cost management, and we can do a lot of cost management with the software that operates the chargers. So both of the partners I mentioned, ChargePoint and InCharge, they've got software that will manage the charging to try to reduce the electricity bill, but still get the vehicles charged to the point they need by the time they need them. But you're still going to have some vehicles that come in and, hey, we've got to run this truck twice today because we had a driver who was sick, and we got to use the fast charger at lunchtime. And you're still going to have all these events where you want to be managing the cost with smart, intelligent software and storage. And so that's really, I think, kind of the secondary consideration. And it's after those measures have been taken that you can make a little bit more return on your system. Maybe you can improve the ROI of your system by supporting the grid with some kind of a vehicle to grid application. Um, and we think that's still a few years away before we see mass adoption of that. There are, of course, technologies that are available and ready today, but there are very few utilities that have programs in place to actually allow you to put energy back onto the grid and get paid for that. So there's a lot more that can be done in the near and medium term with changing the way you're using energy at your site. But as far as putting energy back onto the grid, those opportunities are fewer and farther between. There are pilots. There's pilots in New York. There's pilots happening in Northern California. We'll get to the point where those are more mass adopted, but right now we think that it's still more important to get the operations really sound.
Well, I appreciate that. And one other question. So you put in, you talked about having battery and capacity. So you got these big solar and you got a battery there. Are we talking lithium batteries? Are we talking flow batteries? What kind of battery storage are you using, not on the truck, but in these facilities?
Yeah, it's always kind of on our radar to be watching these other kinds of energy storage, the developments that are out there. We're using all lithium. Lithium iron phosphate tends to be kind of the dominant. There's different flavors of lithium batteries too. Lithium iron phosphate is kind of a favorite for stationary storage projects. It's a little bit heavier than some of the other lithium types that you might want to use in a vehicle, but that doesn't matter because it's stationary and it has better safety properties. So lithium iron phosphate won't go into the kind of thermal runaway, uh, you know, problems that some other lithium batteries with higher energy density will. So it's a real good choice for stationary storage. And it's the it's the chosen chemistry of these kind of global companies that really have the balance sheet to give us the confidence. We know they'll be around for the next 15 years. We need to work with battery providers who are large and stable companies because they're giving you a warranty for 15 years, typically, sometimes 20 on this product. And so, other companies like Flow batteries, a lot of times they're a lot smaller and their technologies are not at scale yet, and there's less certainty there, so that they'd be a little less bankable from an investment standpoint.
So Athena sits behind all of this, and like you said, battery storage is a software problem. You've started to describe some of the issues with the battery technologies and how you might optimize and manage the battery. You've then got the vehicles and these drivers who do or don't do what they're supposed to do, and you've got an operational consideration, and you've got charge point and in charge. You run, charging profiles to optimize, the battery charging. This is like a massive command and control problem. Who's in charge?
Who's in charge? The customer. The customer's always right. It's an interesting question. We have a real partner ecosystem right now where we're supporting the customer with our partners, and we're integrated so that the systems will work together and not fight each other, but we're not sitting one on top of the other. Where our partnership, the way our partnerships with charge management companies are set up, is the charge management company operates the chargers, the connection between the charger and the vehicle, all the tools that the driver sees, the app on your phone that might tell you where the nearest charging station is. That's their domain. They've got all that. And we manage the power flows. So when there's a charge happening, choosing which source is that energy going to come from? Is that going to come from the battery or from the grid or from the solar, if there is solar, or is the grid down and we're operating in a microgrid? So we're operating the power flow side of it. And if we're able to integrate with that platform, we can find out what it's going to do. We can tell it maybe what what it might be nice if it didn't charge right now, if it has that option because energy is expensive, but we're not sitting on top of it, forcing it to do anything, and they're not sitting on top of ours. We're really working as partners and equals with different roles.
That's really interesting because what you're basically saying is the vehicle might say, I need to be charged by 6 in the morning, and I've got 8 hours to live with 4 hours of charging. And you then go, well, it's cheap at this point, it's dirty at this point. We recommend this period, and you only give them 3 hours, and they go, no, no, I need 4 hours. So there's kind of like a machine to machine negotiation, which then leads to an optimal profile being created. And presumably in there, the customer, because the customer is always right, has chosen operational right at the top of the tree, then maybe cost, then maybe carbon, then maybe local generation, and they can tweak that formula with a customer input. Athena does the genius and then communicates with the chargers and the other software systems you're working with to enable the optimal outcome to occur.
You're hired.
Yes, I've just achieved a life goal. Brilliant.
I'm not sure whether to put you on our marketing team or our data science team because that is right. We really have to think about those prioritizations and recognize this was kind of that buyer's journey or the operator's journey I was trying to describe earlier. Is that the prioritization will change over time, right? As the operators get more and more confident with the charging, with the pairing between the vehicle and the charger happening every time without fail, then they'll move along this kind of Maslow's hierarchy of fleet operation, right?
I'm going to use that, by the way. Maslow's hierarchy of fleet operation.
Well, I think we've done a pretty thorough journey on this conversation. We've gone all over the place. I guess as we pull it together, for me, it's interesting just to see the complexity of managing a simple problem in my mind, right? So as Neil pointed out, that what seems to be simple at face value is quite a bit more complex, right? When you start laying the layers of logic on, and I think that's what we want to achieve with the EV mini series is kind of expose those kind of thinking and go there. Any final thoughts as we bring this together that you want to share with our audience?
I think one of the things that a theme I do try to bring people back to is acceleration, and that's one of the things that I think is so exciting about the projects we've done with Penske, with Sysco. If you'd asked me 5 years ago about electric trucks, I would have said, "Oh, that's 10 years away." That's way out in the future. Like cars, yeah, they're starting to pick up, but electric trucks are just way out there. And I love how much we've just accelerated. I don't, I can't say that it was one particular thing that did it. I think the world kind of came together in a strange way during the pandemic, kind of maybe a global awareness increase, and then of course some major federal incentives and but this is a global trend, and so it's really exciting to me to see the acceleration. We see companies, corporations putting climate-based goals, science-based targets out there, and in general they're always accelerating. They're pulling them forward. You very rarely hear corporations saying, yeah, we pushed our climate goals back 10 years. They're pulling them in, and they're competing with each other to do it more. And that's something I'm really excited about, and I just want to see more of.
This is a fabulous journey we've been on, from the shoebox in the coffee shop that controls the battery storage system to the hierarchy of fleet operation. But we've talked a lot about electric vehicles. What's your personal opinion? What's your view on EV? Where do you see it going in your life?
Well, I love how many options there are now. A couple years ago, you had one or two, right? It was a Leaf or a Tesla, and now we've got options where if we, for various reasons, I didn't want either one of those. So now we've got so many more choices, and they keep coming out with more every year. So we've got a deposit in for an ID4, which is perfect for our family, right? That's gonna be. It's got room for the kids and the dog in the back, and it's so cool. Now you get to go and pick all exactly what you want, and it gets made to your exact spec, right? The various features and color that you want and all that. So I think it's really exciting the way the technology has allowed us to have choices like that are a much more broad set in the EV sector now.
Well, Tad, I appreciate you being a guest. Our audience, I'm sure, enjoyed that. Thank you so much for being on the show today.
Hey, it's been a real pleasure. Thanks for having me, Chris and Neil.
For our audience, we hope you've enjoyed this episode as much as we have. Making it's been a fun time. We've enjoyed it. If you're not a subscriber, subscribe. Listen to the entire EV miniseries. There's lots of content here. Find us on YouTube. Find us where you get your podcasts. Find us on Facebook. But we look forward to having you subscribe, and we'll talk to you again in the next episode. Bye-bye.